Lesson 3.4, using the quadratic formula. How do you solve quadratic equations using the quadratic formula? So first, when would you use the quadratic formula? You would use it when you had a ax squared plus bx plus c quadratic function. If you do not have an x squared part of the equation, you cannot use your quadratic formula because it's then not a quadratic equation. If you have it in this form, then you're able to use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The entire thing is the numerator, and all of this is over 2a. The b squared minus 4ac, all of that is inside of the square root. So now we're being asked a question. Solve this problem, solve this equation using the quadratic formula. This is currently not in the form that we need to be able to use the quadratic formula. It needs to be equal to 0. So we need to subtract 5 from each side. So I have x squared plus 3x minus 5 equaling 0. The very first thing you had to do is that the equation needed to equal 0. Now you're supposed to identify your ABCs. A is always the value in front of the x. So my A is a 1. A is always the value in front of the x squared. So my A is a 1. The B is always the value in front of the x. So my B is 3. C is always the number without an x. So my C is a negative 5. Now I'm going to plug it into the formula. I always start by writing the entire formula exactly the way that it is, so I make sure I don't forget or lose anything. To help you with the first time in learning this, A's are all going to be 1, which means this is going to be a 1 and this is going to be a 1. My B's should all be 3's. So this should be a 3 and then a 3. My C should be a negative 5. There's only one C. It's the 1 right there. So we're going to rewrite it, making sure those go in the right place. So x equals negative, I need whatever the blue value was, plus or minus the square root of, the blue value is going to be raised to the second power, minus 4, times the orange value, times the green value, all over 2 times the orange value. My blues were all 3's, so 3, 3. My oranges were all 1's, so that's multiplied to a 1, multiplied to a 1. My green was a negative 5, multiplied to a negative 5. The B was brought to the second power. So we have x equaling the opposite of 3 is a negative 3, plus or minus the square root of, the entire quantity of the blue squared is 9, negative 4 times 1 times 5 is a plus 20. This is all over 2. Continuing to simplify the problem, x is negative 3 plus or minus the square root of 29 all over 2. We need to see if we can prime factorize 29. 29 is, I can't think of anything, it's because it actually is prime. Since 29 itself is prime, there's no square root of 29. So this right here is your final answer. There are 2 of them. So x is the negative 3 plus the square root of 29 all over 2. X is also that negative 3 minus the square root of 29 all over 2. The plus or minus meant there were 2 answers. So we have 2 x values. Let's do another practice problem. We need to solve the equation using the quadratic formula. Our problem already equals 0. So it's set up correctly to be able to use x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I need to identify my a, my b, and my c so I can plug it in appropriately. A is the value in front of x squared, it's 1. B is the value in front of x, it's a negative 6. C is the value with no x variable, it's a 4. Making sure that I get this all correct, my A's are all going to be 1's. My B's are all going to be 6's. And my C's are all going to be 4's. So I'm going to rewrite this equation without the variables, but keeping the colors. So simplifying, we have the opposite of negative 6. The opposite of negative 6 is a positive 6, plus or minus the square root of the entire quantity of negative 6 to the second power is 36. Negative 4 times 1 times 4 is a minus 16 all over 2. So we have x equaling 6 plus or minus the square root of 20 all over 2. We need to see if we can simplify 20. So let's see if it's prime factorized. 20 can be 2 times 10. 2 is prime, 10 is not. 10 breaks up into 2 and 5. So if I were to prime factorize 20, I'd have 2 times 2 times 5. Remember, if things can pair, they escape. So a pair of 2's got to escape. So I have x equaling 2 plus or minus, you said the 2's escaped, the 5 did not. All of this is divided by 2. Because I can see this term can be divided by 2 and this term can be divided by 2, that means that I could divide the entire problem by 2. So 6 divided by that 2 was 3. This is a plus or minus. 2 divided by 2 is 1, so it's just 1 square root of 5. So I have two answers. X is 3 plus the square root of 5, and x is 3 minus the square root of 5. And so right here, what did we do? We divided by 2. And the reason why we divided by 2 is because you can simplify your fraction, and you need to know how to simplify fractions. Our next practice problem, we're supposed to solve this using the quadratic formula. It is not equal to 0. So the first thing we need to do is we need to make it equal to 0. So I have 2x squared plus a 7x plus a 4 equaling 0. Now that it is an x squared x, no x, equaling 0, I can use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. To be able to use it, I need to identify my a, b, and c. A is a 2, b is a 7, c is a 4. My a's are all going to be orange 2's. My b's are all going to be blue 7's. My c is going to be a green 4. So I'm going to rewrite this problem, substituting in my colors. So simplify my problem. The opposite of 7 is a negative 7, plus or minus the square root of 7 squared is 49, minus 4 times 2 is 8, is a negative 8. Negative 8 times 4 is a negative 32. All of this is divided by 4. So I have negative 7 plus or minus 49 minus 32 is 17. So I have the square root of 17 all over 4. 17, can I prime factorize it? I can't. 17 is actually prime. There are no coefficients that can actually simplify, so this is our final answer. You have negative 7 plus the square root of 17 all over 4, and you have negative 7 minus the square root of 17 all over 4. Two answers. Our last practice problem, we need to solve this equation using the quadratic formula. It's currently not equal to 0. So I'm going to subtract the 13 from each side so it is equal to 0. I have a negative x squared plus a 4x minus a 13 equaling 0. Now that it equals 0, and I have x squared, x, non-x, I can use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I need to identify my a, my b, and my c. The a is negative 1, the b is a 4, c is a negative 13. I'm going to rewrite my equation with my colors. So simplifying, I have the opposite of 4, which is a negative 4, plus or minus the square root of 4 to the second power is 16. And negative 4 times a negative 1 is a positive 4. Positive 4 times a negative 13 is a negative 52. This is all over negative 2. x is negative 4 plus or minus 16 minus 52 is the square root of negative 36 all over a negative 2. I need to separate that negative 1 from the 36. So I have x equals a negative 4 plus or minus. Here is my negative 1, and then the 36 needed to be split all over negative 2. X is negative 4 plus or minus the square root of negative 1 we know is I. The square root of 36 is 6 all over negative 2. I can see that this can be divided by a negative 2, and this number can also be divided by a negative 2. Since both numbers can be divided by a negative 2, we can simplify all of it. If both of them did not, you would need to leave it alone. So x is negative 4 divided by negative 2 is a positive 2, plus or minus 6 divided by negative 2 was that negative 3, and now we just need I, so it's 3I. So there are two answers, 2 plus 3I and 2 minus 3I. So that was a positive 6 divided by negative 2, which gave me the negative 3. That was a negative 6 divided by a negative 2, which gave me the positive 3. So positive and negative 3's are right there, and so we have two answers. There is one problem left on this page, and there are two problems left on the next page. Please do those three problems for independent practice.